Notice how it has a transparent back, basically. It still has columns in the back. And you don't see the columns here. That's because that's part of the cave. So the cave rock face sort of, we're behind the cave wall now. So technically if there was collision detection, this wouldn't be allowed. But this particular area does not have collision detection. And that's a sort of hand-wavy way to say that I have not implemented collision detection, but that it's expected to be implemented. And there will be something called a realm, which is an area, or maybe a chunk is a good word to describe it. And a realm will be governed by laws, some of which are things like collision detection or gravity, or all of the settings that a particular server has. You want to have sort of a hyperlinked set of servers basically that have various laws. I call these realms. But that will be for another stream, I believe. This one, I want to try to get voxels working. By voxels, I mean the dynamic data structure that creates a voxel, basically. I don't suspect there will be much talking in this particular stream. Is it even live? Yes, I waited for it to go live. It is live. Okay. So I would like to be able to take OBJ files and convert them into voxel representation. So this is OpenSCAD. You can convert this to STL or maybe an OBJ. STLs usually get converted into G code. It'd be cool to convert just arbitrary OES into voxel data. And then a really good voxel format that I use is the .vox format. That's what this is saved in, so this is .vox. I believe it's probably, I imagine, a quite simple format with voxels laid out and probably containing like float 3 and a color that's also some sort of like float 3, something like that. There's probably a lot that can be associated with a voxel, but there's data associated with the voxel, just position and color mostly. So part of the mission for voxels is to be able to render the .vox data file in the same way that this magic of voxel can render it. And so to do that, I will need some dynamic memory, or I will actually use static fixed size memory broken up into chunks. And one thing that this will allow me to do is this will allow me to basically treat each relative space as its own size of voxel, which would allow me to, have macro voxels and then also have objects that are made of micro voxels. I think that's pretty important for the engine. So I have implemented voxels, I think 3 times now. The voxel implementation started off with individual voxels, which I think I can pull up an example of. It was a pretty cool system. It caused problems when I started to do Minecraft worlds, and so I switched to more space. It wasn't even space saving. Actually, I think it was. I switched to some sort of chunk-based meshing system. It was space saving in the buffer itself. And this caused some slowdown performance in the dynamics of the voxels, and so I made the choice to rip out the dynamic voxels, basically. But it was a really cool system. I think Reddit is probably the best place to get an example of this. What is going on in the esoteric Reddit genre here? Okay, so that's actually a cool screenshot there. So if I go to my posts and I just go to my top posts, where is this showing? Oh, let's go back. Feed options, top. All time, probably. Okay, this is it. Okay, so 3 examples here. You can see a maze getting solved. You can see an audio visualizer visualizing music back there. And you can see a neural network visualizer that has statically rendered the weights of a neural network. Oh, also this was Minecraft clickable. The problem is that it was pretty slow on my machine, and what else is the problem? I think it was probably just the way that I was rendering it. I don't see any reason why, given the skills I have now and understanding of graphics that I have now, that I couldn't make this work in an efficient way. So that's sort of the plan. I'm going to go through the various experiments that I've done and sort of get them working and get maybe feature flags for them, and then as a sort of main challenge, I will get like a high performance version of what you see here with maybe a world loader and chunk based world loading, and of course I'm not going to ditch any of this, so it will load this as well. So that's sort of, I think, the goal I have right now. So let's see what that takes. It's been a while since I've worked on like GPU stuff, so maybe let's start from the basics. Godeka says, Trippy, nice to see this project. Thank you. Comported Box is amazing, says, should I make the default login manager for your HackMatrix distro called Matrix? The default login manager. I think the default login manager should probably just be HackMatrix itself. Like it should just boot into HackMatrix, and I was thinking that each machine, it would just be one login per machine basically, and so each login you would just have an SSH key and a GPG key, and then when you boot up the machine, it would just boot straight into HackMatrix and then log you in based off of that key, I think is the idea. Which does mean I'll have to basically make each download different so that each person gets a different GPG key, or I create them after they boot. That'll be interesting. Interesting problem to solve. Okay, so one more time as a review, we want to be able to render high definition, highly dynamic, or any aspect ratio, any size voxel using the .vox format that is standard with Magic of Voxel, and we want them to be as dynamic as what you see in this video, specifically with the puzzle or the maze, the audio visualizer, and the neural network visualizer. And we also want it to be able to load Minecraft worlds. And so in a few minutes I'm going to just mindlessly conk out and just start trudging through some code to maybe resolve this. Hey, look at this. The HackMatrix minimap painting progression here. I'm turning these yellow blotches into buildings with pink-purple paint. Anyways, posts. I need to see the post with the Minecraft world. There was a Minecraft loader. I have to scroll through a lot of this. That's not it. That was very recent, actually. Oh! Okay, so there's not a really good example of this. But this is like a loaded Minecraft world with mostly third-party block textures with like maybe the most common block, or maybe the most like 2 or 3 most common blocks, my texture, which is this Emacs green and Emacs or Spacemax gray block, which I think is supposed to represent grass, maybe? Grass block? Anyways, so I want to just sort of re-enable all of those features that I experimented with. Maybe I have to rewrite them all, I'm not sure. Okay, it's time for me to conk out and work on this, so I'll see you guys on the flip side, yo. That's so old now. Yeah, can I use this with my stream? Okay, I think it might go to NCS. Deepacker. It's just really disheartening that I can't find rights reserved, unauthorized redistribution. Okay. NCS, you're undefeated once again. Best of 2026. I'm gonna keep it pretty low because I think it's going to get pretty annoying if I keep it too high. Yeah, that's very annoying music. Jeez, not a chance. Okay, let's do just copyright free Japanese math rock. This might actually get a little too annoying too. We can walk it for a moment. Okay. Okay, so I just added in a new type of, let's say, renderer. This is called the dynamic object renderer. I'll show the code in a minute if it works. Okay, that's a good sign. I'm not sure why it's black. Okay, so it's not moving, which is to be expected. So let's go and I guess look at this code. So I think I made this before I made like proper object models. But this is like maybe a procedurally generated object. That music might be a little overwhelming for the microphone. This is one way to find out. I'll keep that open for a moment and see what that does once it gets a little louder. Okay, so I want to go to the tick and turn the movement of the dynamic object back on. And I'll make that again and then look at the volume. I think it's probably okay. I could just lower the volume of that. Chat, tell me how the volume is. Is the volume good? HackMatrix, HackMatrix. Okay, so that's built. Let's rerun it. Do it to right there. We have to watch out. It should move. It's very slow. Slow but sure. There it goes. So this predates the positionable system as well, so it's not modifying any positionables, it's just, I guess, incrementing this dynamic object's position. It's cool. It's not super useful for entity component based programming, which is sort of one of the reasons why I ditched it. But I like having the system in here. Maybe I should just document it or something. So the question I have is, can I change its color? And I guess what can we learn from the code about rendering voxels? So let's answer those two questions. Okay, we're back. Let's take a break. We're down to the vast horizon, which is actually only a quarter of a kilometer away, and then dive back into the code, into our matrix cubicle. a dynamic cube. Okay, let's take a look at what this code is attempting to do, or what it does successfully. So it's created a dynamic cube itself, is creating with a position and a size. So the size represents, basically it's not a cube, it's a cube, three-sided thing, or if I mean four-sided thing, wait, four sides, I'm retarded, six-sided thing. Just a standard cube, but sides don't have to be equal. You can have three different sizes for each axis. So I'm not sure what this renderable thing is yet. I wrote this code, so I'm just having to relearn it for myself. Okay, so there's a position for the object, for the cube, and then you have these vertices which represent the faces, or the corners to create the faces. But each corner can be specified multiple times. For instance, negative hx, negative hy, negative hz is specified on the back face, as well as on the left face, as well as on the bottom face. Okay, and so that lays out the positions in physical space, and then you need the indices that create the triangles for the face. So I think that's a pretty simple concept to grasp, but basically we're drawing triangles with the points that we specified above. So 0, 1, 2, 0, 2, 3. And it's going to follow that pattern 4, 6, 7, 6, 4, 6, 5, 8, 11, 10, 8, 10, 9. That same pattern, just because of the way that it was, just because of the way it was laid out up here. It was laid out up here in a structured way, so the indices themselves will have structure. But the fact that the indices can be specified indicates that your vertices actually don't have to be structured, because you can provide the structure via the indices for this particular rendering scheme. Okay. And so then it fills the vertices into this renderable thing, and then this renderable thing presumably gets yeeted at the GPU. So it takes the object, and I'm not sure what this. So this is creating its renderable. I don't know how often it does this, but it takes all of its vertices. Position plus vertices of indices. Okay, so it's just flatlining all of the indices into flat indices. So it's using this indice vertice arrangement, or IM, and I'm fairly confident that I mostly wrote this myself. And then I'm putting all of the vertices into this this vector, which will then just be converted to just a data pointer that gets yeeted into the GPU. So it has a concept of damaged. So every time it gets damaged, it will have to, something changed about it, and so it will have to have its renderable recreated. So the vertices will change. They'll all, in this case, be translated by the whatever this addition is. This is strange. I think probably a set position like this should probably set damaged. I'm going to be evil. This just returns the read-write mutex. I'm almost thinking that the move needs the read-write mutex. It's a bit sus to me that it doesn't have it. Maybe that will cause a crash at some point. I'm kind of concerned that if I add this, I add this to move, that there's going to be a lock. Okay, I think this will just work, actually. So let's run that, just to verify. Bruh. Surely it wasn't from this, right?